Hello and welcome to my 11 plus exam videos. These are some of the questions I have picked up from a specimen paper. So let's get started. The first question is: three people stand in a line in order A, B, C. The people then change positions in the line so that no one person is left standing in the same position as they were to start with. For example, C, A, B. So if we write it down, if we have A and B and C, these are the three people. Now three positions they have taken up, and the next position they have given us as an example is C, A, B. So you see none of the positions are being repeated. Each person has a new position. So what will be the third option? The third option will be A has got the first position, then second, then we will give A the third position, and then C is here, so we can't have C in the first position. B can come here and C gets here. So what is the other possible order? It is definitely B, C and A, right? Maybe 1 second. I'll just make it a darker color when I write. So it's B, C and A. Okay, so that's the answer. For the next one, they're saying it's similar, but now there are four people. So instead of just having A, B and C, we have A, B, C and D. So now how will this work out? Okay, so let us write it down again. A, we have B, then C and D. Now four people, so A has taken up the first position, so A can't take the first position anymore, so we will keep moving A to the second position, then A is in the third position, then A is in the fourth position, and we will adjust B, C and D accordingly, and so that none of the positions are repeated for any of them. So once A has this position, I can put B here, and C can't come here, D can be here and C. Now in the first position I can have C now, and I can have D now and B. Then I can have D here, I can have C here and B here. So this way you can see that none of the positions are being repeated for any one of the people. Each time they have different positions. Okay, so how many options are there? There is 1, 2, 3 and 4. So there are 4 possible ways of doing this. So that's your answer, and this is the way to do it. So this is what is your answer. That is what you have to write. So this is the working out that you show, and that's the answer. Okay, so let's go to the next question, which is the diagram below is a Venn diagram. Amy needs to write some numbers inside the circles. Any number written inside one circle is a factor of 12, and any number written on the other circle is a factor of 16. Two numbers have been written in for you. Help Amy to complete the diagram. Okay, so let us write out the factors of 12. Factors of 12 are 1, 2, 3, 4, 6, 12, and factors of 16 are 1, 2, 4 times 4 is 16, 2 times 8 is 16, and 16, right? So the factors, the common factors are 1, 2, 4, isn't it? Yes, those are the only common factors. 6, 12, 8, 16. Yeah. So we have 1, these are the common factors. I hope it's clear. And then the other factors are factors of 6 and factors of 12. So what are the factors of 12 that don't belong to the common part? They are, we have 2 out 3, okay, and 12. Similarly, the factors of 16 that do not belong to the common part are, we can't have 2, we can't have 4, we can certainly have 8, and we can have 16. So I think that covers all the numbers. 1, 2, 4, yeah, 3, 6, 12, yeah, and 8, 16, yeah, and 1. So that answers the question. Okay, the next one is a square number is what we get if we multiply a whole number by itself. Okay, a cubed number comes from multiplying a number by itself and then by itself again. So 9 is a square number because 9 equals 3 times 3, and 8 is a cubed number because 8 equals 2 times 2 times 2. 1 is both a square and a cube, we know that. Find another number bigger than 0 that is both a square and a cube number. Okay, so the first thing here is, please bear in mind, the number has to be a square and a cube. So let us start with the squares. Okay, we can also start with the cubes, but we'll start with the squares because I think I'm more familiar with the squares. We use squares more generally than we use cubes, so I will start with the squares first. Let me list out the squares. So which are the squares? We have 1, we not 2, then 2 square is 4, 3 square is 9, 4 square is 16. Is it a cube? No. 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64. Aha! I got my answer because this is 8 times 8, and it also equals 4 times 4 times 4. 4 times 4 is 16, 16 times 4 is 64. Okay, so your answer is 64. Both a square and a cube number. Okay, next question. So the next question is telling me that they have given us these shapes. So I have triangles and I have squares, and when I add up 3 triangles and 2 squares I should get 16. If I add 2 triangles and 1 square I should get 9. So I have to find what is triangle and square basically. So how do we do that? So we will make some assumptions here. As you know, I think that we will assume that triangle equals x and the square equals y. Then it's easier to solve. We will try and make equations. So from the first one we get that 3x plus 2y equals 16, and the second one is 2x plus y equals 9, that is number 2. So, or we get y equals 9 minus 2x. Okay, so using this in 1, so if I write using this in 1, what will we get? 3x plus 2 times 9 minus 2x equals 16. So 3x plus 18 minus 4x equals 16. So changing sides, we get x equals 2. 18 minus 16, so that's 2. Okay, so if x equals 2, then y equals 9 minus 4, that equals 5. 2 is 4, right? So we will have, so what we get is my triangle equals 2, yeah, and y is the square equals 5. So this will be 2 plus 5 equals 7, and the next one is 5, isn't it? Yeah, I think that's right. The next question is, Jacqueline and Sophia stand facing one another. At exactly the same moment, both girls start to turn steadily on the spot. Okay, it takes Jacqueline 3 seconds to make one full turn, while Sophia takes 4 seconds to complete one full turn. How many times will Jacqueline have turned when the girls are next facing each other? Right, so how do we work it out? So I have Jacqueline and I have Sophia, and we will try and make a table here showing their turns. So 3 seconds, mind you, so, and it's the number of seconds that we will be counting. Okay, so for Jacqueline in 3 seconds, and in Sophia, when they at the start they are meeting one another, and then after 3 seconds Sophia will have 3, because she takes 3 seconds. That's the start. That's one turn. The one turn for Jacqueline. Okay, so then we are pegging it to Jacqueline's turns. Okay, so 3. So next, again, the next turn she will have 3, done it in 3 seconds. Now Sophie will take one turn more to complete the to make a full turn, not one turn, 1 second more to make a full turn, and plus, because there is 2 new, because why I'm saying old and new is like I am assuming that is the continuation of the turn from the previous one, and then I'm adding a new turn to it. So after 3 seconds she will have done completed 3, she will still need one more turn to one more second to complete her turn, and then after she has completed her turn she will again start her new turn or another round of turning, because there is still 2 more seconds left. So this is the turn number 2. This is the second turn. So again this will be 3, and she has learned 2 new, so it will be 2 old plus 1 new turn. That is third turn. And the fourth turn, again this is 3, so she has done 1 new, so she will have 3, completed 3, so then be 3 old, so then they meet again, so So here they will meet again, okay, and then they will start again a new cycle will start after the fourth turn. So how many times will Jacqueline have turned when the girls are next facing each other? So Jacqueline will have turned 1, 2, 1, 2, 3, 4 times, 4 turns when they are again facing each other. Okay, so I think this is the last question in this video. So thank you so much for watching. Thank you for your time, and I will be back with more videos, more questions, more specimen papers, and more lots of questions more. Thank you so much for watching. Bye.